Hey guys, in this one we're going to learn three very important rules with logs called the laws of logarithms. Now these guys are going to allow us to simplify and solve otherwise extremely complicated expressions and equations. So I'm going to introduce you to those in here, and then in the second part of the video I'm going to run through a proof of each one of them. I'm going to show you where they come from. Now you might not necessarily need to know these, but one thing that always annoys me in maths is being told something is because it is. No, there's always a perfectly good reason, so where there's a proof, I always aim to show it to you. So you don't need the proofs, but if you're interested, it's nice to see them, and also it's a very good test of your knowledge with the logs. So maybe actually I highly recommend you to stick around and go through them with me. Okay, so here are the laws of logs. Okay, so I'm well aware they look a little bit mental at first glance. When we start using them, which we're going to do in the next video, to simplify expressions, they will become like second nature extremely quickly, I promise you. So law number 1 tells us that log base a of x plus log base a of y is equal to log base a of x times y. So number 2 tells us the complete opposite. So log base a of x minus log base a of y is equal to log base a of x divided by y. And then law number 3 tells us that log base a of x to the power k is equal to k times log base a of x. So get these down, we're gonna need them. It's important here to realise with the top two, the logs have to be in the same base. If they're not, the laws don't apply. We can change the base, but that's a story for much later on. So get these down, and now we're going to have a look at a proof of each one of them. Okay, the first one then. So we want to prove that log base a of x plus log base a of y is equal to log base a of x times y. How are we going to do this then? Well, first of all, we're going to define each of our separate logs, log ax and log ay. We're going to define those as different constants. So I'm just going to pick two letters, F and G. I think most commonly used is M and N, but they sound exactly the same, so I'm picking two that don't. So I'm going to say log base a of x is equal to F, and log base a of y is equal to g. So why am I doing this? Well, it's so I can then write the logarithms in index notation. So if log base a of x is equal to f, this is equivalent to saying that a to the power of f is equal to x. And then if log base a of y is equal to g, that's equivalent to saying a to the power of g is equal to y. So notice now we have an x and a y on their own. So we want to end up with a log base a of x times y. So it seems logical we're going to need an xy. So to get that, we're going to have to multiply our equations together. So if we do a to the power f times a to the power of g, that's going to give us x times y. Now using our rules of indices, we can combine the left hand side to one single a term. So we can say this is a to the f plus g, which is equal to x times y. So what we need to do now is log both sides. Before we do that though, I just want to remind you of something, and that is if we take the log base a of a to the power x, remember that is asking what power of a is equal to a to the power of x. So log base a of a to the power x is just x. In other words then, taking the log base a of a to a power is just equal to the power. So our next step then is to take the log base a of both sides. So log base a of a to the power f plus g is equal to log base a of x times y. Now on the left, using this cheeky little statement here, on the left hand, log base a of a to the power f plus g is just f plus g. So now we have f plus g equals log base a of x y. Now remember back at the start we called log base a of x f and log base a of y g. So we've got log base a of x plus log base a of y is equal to log base a of x times y. QED, there's our proof. Okay, now we want to prove law 2, so we want to prove that log a of x minus log a of y equals log a of x divided by y. So, our first step is exactly the same. We're going to define log a of x and log a of y as constants f and g, and then write them in index form. So again, we've got a to the power f is x, and a to the power y, a to the power g is y. So, this time we need to end up with an x divided by y. So, to end up with that, we're going to have to divide the first equation by the second equation. So, if we call the top one number 1, the bottom one number 2, then equation 1 divided by equation 2 is going to give us well a to the power f divided by a to the power g, and that is going to equal x divided by y. Which is good, we've got our x over y term. So, using our rules of indices, a to the power f divided by a to the power g is a to the f minus g, and that is equal to x over y. Now we take the log base a of both sides, so log base a of a to the f minus g is equal to log base a of x over y. Okay, now remember the left hand side is saying what power of a is what power of a is a to the power f minus g. So it's just f minus g. So f minus g equals log base a of x over y. And then again, remember at the start, we said that log base a of x was equal to f. And log base a of y was equal to g. So we've got log base a of x minus log base a of y is equal to log base a of x over y. Again then, there is law number 2 proven, QED. On to law number 3. Okay, last one then, we want to prove that log base a of x to the k equals k times log base a of x. So we're going to do this in a very, very similar way. We're going to start off just by saying log base a of x is equal to f again. So not log base a of x to the power k, just log base a of x. Then again, in index notation, we know then that a to the power of f is equal to x. Now, we need to obtain an x to the power k. So, all we're going to do here now then is raise both sides of this to the power of k. So we would get a to the power k times f is equal to x to the power of k. So there's the x to the power of k that we need. Now we're going to take the log base a of both sides. So log base a of a to the power k times f is equal to log base a of x to the power k. Now, on the left hand side, again that is asking what power of a is a to the power of k times f. So the left hand side is just k times f. So kf is equal to log base a of x to the power k. And then remember, at the start we said that log base a of x was equal to f. So on the left we've actually got k lots over log base a of x is equal to log base a of x to the power k. So again, QED, we've proven the third law. Jobs again for this video. So in the next one we're going to look at using the laws to simplify expressions. Take care guys, take it easy.